All right, so this is number 35 from page 234. So they gave us a function. It's a fourth degree polynomial. By the fundamental theorem of algebra, I know it's going to have 4 zeros. And they gave us one of those zeros. By that whole complex conjugate zeros theorem, I know that if 3 minus 2i is a 0, then 3 plus 2i must also be a 0. And then I'm going to work on finding my factors. And I've got 2 more zeros to find. So what I'm going to do is I'm going to make some factors out of these, some linear factors. X minus 3 plus 2i would be one of my factors. X minus 3 minus 2i would be another one. And I know I'm going to have 2 more factors here. And from those 2 factors, I'll find my last 2 zeros. So what I want to do is I want to divide out these 2 zeros, but I don't want to use synthetic division. I don't want to divide when I've got i's and stuff in there. So what I'll do instead is I'll go ahead and multiply these 2 things together. That should give me a quadratic factor that doesn't have any imaginary parts in it. So I'm going to use my shortcut to do that. These both have x minus 3's, and then one's got a plus 2i, one's got a minus 2i. So I'll use those, my a and my b. So I'm going to do x minus 3 squared, which would be x squared minus 6x plus 9. And then the shortcut is square the real part and then square the imaginary coefficient and add them together. So this would be plus 4. So when I work this out, we should end up with x squared minus 6x plus 13. And we practiced on Thursday in class multiplying those things out. And I encourage you to try using the shortcuts, try using the box method, whatever is going to get you from here to here. So my strategy next is going to be, let's figure out what the other quadratic factor would be. It's got to be a quadratic because we got to end up with a 4th degree. So let's take the original 4th degree polynomial and divide this out. And I'm just going to use polynomial long division for this. I'm going to put a link to, I got sent a video, interesting video over the weekend. And another way to do division I thought was pretty neat. I'll post it on Canvas. Anyways, let me get this done here. So x squared goes into x to the 4th, x squared times, multiplying gets me x to the 4th minus 6x to the 3rd plus 13x squared. And then we subtract that. I should see the first term cancel. It does. Yay. Ooh, the second term cancels too. That's nice. And then 11 minus 13 would give me negative 2x squareds. Bringing down the rest of it. Then I need to do x squared into negative 2x squared. That's minus 2. Minus 2 times that is negative 2x squared. Minus 2 times that would be positive 12x. Ooh, that's nice too. And a negative 26. Yay. Happy. We got the remainder of 0, which we should have, right? Because we knew that was going to be a factor. So my quadratic factor is x squared minus 2. We'll use that to get our last 2 zeros. We'll set that equal to 0 and solve it. X squared minus 2 equals 0, so x squared equals 2. Take a square root on both sides. X equals plus or minus root 2. So I got root 2 and negative root 2 for my last 2 zeros. And those linear factors would be x minus root 2 and x plus root 2. And I think that's all they asked us to do in this, right? Find all of the zeros and write a linear factorization. We got it. Okay. Any other burning questions from this section? 27. Find all the zeros, write a linear factorization. Yeah, we got time to look at that. We'll look at number 27 also from the same section. This one is very similar. We're finding the zeros and doing a linear factorization, but this time around, they didn't give us any other information about it. So we're going to use our calculator. Now, if we didn't have a calculator, this would be pretty easy to guess through and try and find some zeros because our P over Q list would be pretty small, wouldn't it? Like my Q list is 1. So my P list would just be 1 and 5. So there's really only 4 things I'd have to try with synthetic division, but we don't need to do that because we got a calculator. So let's graph this thing and see. And I'm hoping that I mean, it'd be great if we could find three zeros on our graph. But if not, we've got some tricks up our sleeves. So let's see what we see here. All right, I only got one zero. Looks like it's at 1. Let me confirm that. We'll do second calc value. It looks like it's at 1. Confirmed. Yes, 1, 0 is on the graph. So we've got, of our 3 zeros, we have one of them at 1. To find the other 2, we are going to need to divide out the factor we know, which is x minus 1. And that should get us down to a quadratic. And using that quadratic, then I'm guessing we'll probably have to use the quadratic formula to find our last one. So let me set this up. I'm going to use synthetic division. My root is 1. My coefficients, did you catch in this one that you were missing an x squared term? You got to get a 0 in there. It's 1x to the third plus 0x squared plus 4x minus 5. If you didn't put that 0 in there when you did your synthetic division, that would have caused some issues. We should be getting a remainder of 0. Let's make sure that happens. Yeah. So what I found is that I've got x minus 1. I divided that out. My other factor, the quadratic factor, is 1x squared plus 1x plus 5. That's going to give me my other 2 zeros. I'll just set that equal to 0 and solve it using the quadratic formula. All right, B was 1, A was 1, C was 5. -1 plus or minus root 1 minus 20 would be -19 all over 2. Sorry, keep running off the page here. So I'm getting -1/2 plus or minus root 19 over 2i, because there's a negative in there. And that'll give me my last 2 factors, which would be x plus 1/2 minus root 19 over 2i and x plus 1/2 plus root 19 over 2i. And that gives me my last 2 zeros as well. I'll let you fill those in. All right, we kind of need to get moving on here. If you have still got questions about anything from the last assignment, just hang on to those. We'll have lots of time on Wednesday. My hope is that you guys found this last assignment kind of just review of what we've been doing all along, kind of, right? Except now some of our zeros are imaginary zeros. That's really the only thing that's changed from what we've been doing, what we did all last week. So, all right, we are switching gears big time today. Moving on to rational functions. Again, if you didn't get these guided notes, go ahead and grab those now.